Example, a fraction of x male runners and a fraction of y female runners who compete in a marathon races are described by the joint density function f of xy, which is equal to 8xy, where y is between 0 and 1 and 0 elsewhere. The question is, find the covariance of x and what? And y. The solution. We first compute the marginal density function as g of x, which is equal to 4x squared for the interval our x is between 1 and 0. And then also we compute the marginal distribution of y, which is 4y into 1 minus what? Y squared. After getting the marginal distribution of x and the marginal distribution of y, we now get, from these marginal density functions, we have expectation of xy, which is equal to the summation of x is equal to 0, y equals to 0 to 1 of 8x squared y squared dx dy. Remember this one here, 8x squared y squared is obtained by multiplying x, y to this expression, the joint distribution function. That's why we get this. So if we integrate with respect to y, x and y, and we substitute these values as the interval, we shall get 4 out of 9. But remember, our covariance of xy is given by expectation of xy minus the marginal distribution of x and the marginal distribution of what? Of y. So if we substitute in the formula, we shall get 4 out of 9 minus 4 out of 5 times 8 out of 5, which is 4 out of what? 225. So let x and y be random variables with covariance lambda xy. With covariance this one xy and standard deviation sigma x and sigma y respectively. The correlation coefficient of x and y is given by the covariance of xy divided by the standard deviation of x times the standard deviation of what? Of y. Means and variances of linear combination of random variables. How do we get the mean and the variance of a linear combination of variables? Variables can come as a result of linear combination of different what? Variables. For example, if a and b are constants, then the mean of combination of a random variable ax plus b is equal to a constant, expectation of x plus what? Plus b. Expectation of a constant is equal to that constant. It is very important to note that. The expected value of the sum or difference of two or more fractions of a random variable x is the sum or difference of the expected values of the functions. That is to say, expected value of the sum or difference of two or more functions. So this is the function and this is another function. So the expected value of the sum of these two functions is equal to the sum of each expected value of each of these functions, or the difference of the expected value of each of these functions. For example, let x be a random variable with probability distribution as follows. So we have x as 0, 1, and 2 or 3, and the f of x as a third, 1 over 2, 0, and 1 over 6. Find the expected value of y equals to 1 minus x raised to power what? To power 2. In order to find the expected value of this, we need first to expand x minus y raised to power 2. So this one is equal to x squared minus 2x plus what? Plus 1. So applying the law of expected values of random variables, combination of random variables, this one is going to be equal to expected value of x squared minus 2, which is 2 is a constant, expected value of x plus expected value of what? Of 1, which is a constant. And remember, expected value of a constant is equal to what? A constant, which is 1, by direct computation. And expected value of x is the sum of the product of x times x of what? Of x, for a discrete probability distribution. Hence, we can have 0 times a third plus 1 times a half plus 2 times 0 plus 3 times 1 over 6, which is equal to 1. And expected value of x squared is given by the product of x squared times f of x, which is 0 times a third plus 1 times a half plus 2 squared, which is 4, times 0 plus 3 squared, which is 9, times 1 over 6, which is equal to 2. Hence, expected value of x squared, x minus 1 altogether squared is equal to, then we substitute expected value of x squared is equal to 2 minus 2 times expected value of x. 2 times expected value of x is equal to 1, then plus this 1. So 2 minus 2 plus 1, we get what? We get 1. The expected value of the sum or difference of two or more functions. Remember, we were looking at only two functions. Now we are going to look at more than two functions. X and y is the sum or difference of the expected value of the functions. For instance, we have g of x, y, and then h of xy. These are the joint distributions. So equals to the expected value of the individual what? Functions. Okay? So let x and y be two independent random variables. Then expected value of x and y, x times the product of y, is equal to the expected value of x times the expected value of what? Of y. Provided x and y are what? Are independent. Okay? Remember, if they are independent random variables, then the product of the expectation of their product is equal to this, to the product of the expected values of the individual what? Individual functions. So let x and y be two independent random variables. Then their covariance is equal to 0. If they are independent, then the covariance is equal to what? Is equal to 0. For example, x, it is known that the ratio of gallium to arsenide does not affect the functioning of gallium arsenide wafers. which are the main components of microchips. Let X denote the ratio of gallium to arsenide and Y denote the functional wafers refined during 1 hour period. X and Y are independent random variables with joint density function f of x, y, which is equal to x into 1 minus 3y squared over 4 for x between 0 and 2 and y is between 0 and what? And 1 and 0 elsewhere. Show that expected value of xy is equal to the expected value of x times expected value of what? Of y. Solution. We know that the expected value of xy is equal to the integral of x is equal to 0, y equals to 0 to y equals to 1 and x is equal to 1 of x squared times y into 1 plus 3y squared. Remember, our xy is multiplied by this function. So if xy is multiplied by this function, we get x times x, which is x squared. And then y times x, it is y open brackets 1 plus 3y squared over what? Over 4, which is this one here. And then we are integrating with respect to x and with respect to what? To y. So this one is equal to 4 out of what? Of 6 if you compute this. And expected value of x alone is equal to, if we multiply x by this function and then we integrate with respect to y, we shall get 4 out of 3. And if we multiply y by this and we integrate it with respect to x, we shall get this 5 out of 8. 5 out of 8. Hence, when you multiply 4 out of 3 times 5 out of 8, you get 5 out of 6, which is still equal to the expected value of xy. Hence, we have shown that the expected value of xy is equal to the product of x times the product of what? Of y. If x and y are random variables with joint probability distribution of f of xy, and where an a, b, and c are constants, then covariance of ax plus by plus c is equal to a squared variance of x plus b squared variance of y plus 2 into ab and covariance of xy. Remember, this is the variance of a linear combination, okay? Of a linear combination, which is ax plus by plus c. So you get a squared variance of x plus b squared variance of y plus 2ab covariance of what? Of xy. And variance of ax plus c is equal to a squared variance of x, because variance of a constant is equal to what? Is equal to a 0. If x and y are independent, then variance of ax plus by is equal to a squared variance of x plus b squared variance of what? Of y. And the variance of a difference of combinations is equal to the sum of the what? Of the individual components, which is equal to a squared variance of x plus, so remember this minus sign changes to a plus, and b squared variance of what? Of y. If x1, 2, and x3 are independent variables, then the linear combination